Yeah, I think I'll do a quick introduction. I'm a senior software engineer at Elastic. I'm working in the security product under Elasticsearch and more into backend and infra. And before this, I was working at a company, it's called Gojek. And then there, I was managing the platform team, and we were managing a lot of clusters. And it was like a end business. It's similar to Uber and some Paytm, or like they had huge customers. So in that sense, in my last role, I had much closer management of Kafka clusters and dealing with it. And in my last startup, was managing clusters passively, like in Elasticsearch. There's not much active thing. So in the recent times, if there's anything big or missed, feel free to chip in as well. I might miss something, but the high level agenda is, I think this is personally my learnings over time. Trying to not go too much into the administration side of things, but rather anything which is applicable to any producer, consumers, or anyone who is using the Kafka system. Because since we were a platform team, and then we have seen these issues oftentimes with other teams, it could be questions, it could be discussions, or it could have been like a misunderstanding, and then that led to a lot of issues, production issues. So this is the gist of that. I'll try to keep it to the concept, and then if there is anything more you want me to add, feel free to let me know as well. So just to be on the same page, anyone who's also new into this call, we are talking about Kafka ecosystem. And then if you have ever used Redis PubSub or Google PubSub or RabbitMQ, this is similar to like any other PubSub model, right? Just some terms as here you can have multiple producers to the same topic. Topic is the data which holds data. And then consumers can be consuming from one or multiple topics as well. So here you can see there is two producers, which is producing to a topic. And then within a topic, it is a subset, right? So that subset is used for distributing the load across, dealing with reliability and whatnot. So there are producers, there are consumers, there is Kafka Brokers, which has topics, which internally has partitions, which has a split of data in a way. So hopefully everyone, if anyone still have questions on that, we are sort of building on top of that concepts, feel free to shoot. So this is something anyone who started very early on with their consumers, I've seen them facing this particular issue. So whenever you have a Kafka cluster, it's usually deployed and managed by different team, DevOps or platform teams. And then your responsibility would mostly be writing microservices to consume the data from Kafka and write it to database, or you will be pushing to Kafka as events, by doing some operations, right? So we can take an example, on this, we can stick to that analogy. Anyone who signs up into an Uber app, we can send an event to a Kafka, and then there could be multiple consumers listening to the user sign up events. And then one consumer could as well send a promotion. Another consumer could send someone nudge hey, why don't you take your first ride? A different consumer could be listening to a lot of orders, which happens every day, and then probably which sends you, hey, your weekly trip is this much. Same way, if you think about, let's say, drivers, any orders, if you consume by a different consumer, but rather you can tell, hey, this is how much you've earned per month or a weekly basis, right? So in that sense, we are writing consumer for a different purpose. And then the moment you start, you will as well do, hey, consume from Kafka, and then do the processing, and then you keep moving on, right? But the really interesting part is by default, a lot of libraries has internally configured default consumer commits. And then what it means is whenever you consume data, it is assumed in Kafka that like you have successfully processed the messages. But in reality, we will be consuming that user sign up, and then we'll be calling some other microservices or database rights. And then eventually, once all of that multiple transactions is done, then you can say, hey, this particular message is complete, right? Like you've successfully processed. If you don't have, if you usually have the default like commit offset configuration, then you will tend to lose messages because if you have, let's say, hey, 1, 2, 3 messages, but you will move on to message 4, even though the message 3 is not processed successfully. Like specifically, if you say, hey, message 1, 2, 3, 4, and then message 3, you're trying to make a call to external service. And at that particular time, if the external service went down, you've consumed the message from Kafka, but you don't have any means to say, hey, this is a failure, right? So in that sense, you have to disable the auto commit offsets. And like this is a very pseudo code, right? Like you will poll for Kafka for messages. You will process messages, like this could be considered as a batch of messages. And then if it's successfully done, you commit it back to Kafka saying, hey, this particular batch of messages, we are sorted, and then we can move on to the next one. This is really minor, but I've seen like people missing data because of this. And then it's really tricky to say the data loss has happened in Kafka, right? So like we'll touch more on that, but like you should be really wary of that Kafka default consumer offset configuration. The second thing is scalability with respect to partitions, right? I would be curious to hear on like what is your cluster's default partitions like in your teams. But personally, we have changed our strategy over long time. So initially, it used to be like, hey, anyone can create topics, and then the number of partitions per topic could be defined by them. But then over time, what we realized is this, even though the services has bottleneck, your database has bottleneck, people tend to throw more and more partitions, hoping that that could help them scale better. So if you have 100K messages per second, if you have 10 partitions, you are like, in parallel, you can run 10 consumers, and then you can process 10K messages, right? So just in case your latency increases from some 100 ms to 200 ms, now you will not be able to consume the 10K RPS, but rather you'll be lagging, like rather than 10K, it could be 8K or 7K, right? So what people tend to do is, hey, okay, let's increase the partitions from 10 to 50 or 20, whatever. And then that is directly proportional to the lag rate. I've seen a lot of services, a lot of high loaded microservices, and anyone who has a like data contention and then dealing with multiple external microservices call as well as database calls, their whole processing time is really high. But unfortunately, a lot of times they don't look at that monitoring, and they try to scale it really heavily on the partitions. So eventually what we came to conclusion is like most of the times, I mean, this is a magic number for us, but it could be different for you. It's like by default, we only give you 12. And then unless you really have any need, like we will evaluate if you have metrics and whatnot. And then if you have a reasonable justification, then we will expand it to, let's say, 24 partitions. It's not like we want to limit the partition just because like we want to control it, but rather we have seen so many side effects or bottlenecks which is caused because of higher partitions as well, both in Kafka aspect as well as in the consumer sides. I'll touch on it in a bit. The only exception was like we have some, like let's say, hey, location-based data, which comes really often, like a GPS tracking data. Then in that case, it makes sense, right? But like we really have to evaluate, does the use case really need it? And then can you deal with like the services in a lower number of partitions? Because the moment you scale to 100 partitions, there is no way to scaling down the topic from 100 to 50 partitions. So once you scale it up, you can't scale down the number of partitions. So in that way, even though there is only a spike in throughput and then some sudden burst of attack, and then you want to deal with it, scaling partitions might not be the best way to deal with it. So let's take an example, right? Let's dig a bit more deeper. Let's assume the same case, right? You're dealing with orders, and then every order you will usually have like states which is coming to the Kafka. It could be like order is created, order is like you need to find driver, then you complete it, then payment completed, something like that. So assuming in your microservices, you will be listening to the states events of the orders. Earlier, you used to have, let's say, 10 microservices. Within 10 microservices, if there were 10 partitions with Go routines, I mean, whatever threading mechanisms, you will be running 5 or 10 consumers and then trying to process each and every order, that in turn processing payments. So now, rather than 10, if you scale up to 50, the number of operations you're doing on the database also like increases. So it is fine in lower numbers, but when you go to really high scale, rather than 10K, you'll be dealing with 30K, 50K requests per second. So what that means is whenever you're dealing with the writes or any reads, you will be using locks, and then you will have contention. And then usually you would have seen a insert into orders on conflict update, right? Because it's an event, and for every event you have metadata changing, right? Like created, finished, payment completed, you will keep updating it. And in this case, you often would have higher number of conflict. We have even seen that causing the lock being timed out, and then like a lot of transactions being rolled back. It is really catastrophic effect in a sense that like you would think it's just database or it might be wrong queries, but in some sense it was also related with just blindly scaling your partitions and blindly scaling your consumers. The next bit is also to do with the partitions, but like I would simply say this: unless you really need it, you should never use custom partitioning. I've seen a lot of people come up with a use case of, hey, I want ordering, or hey, we want to control some particular fashion of events into a particular partition. Like some modulars or some sort of sharding, if they try to bring it in the data, right? It usually backfires in that sense. Also, I've seen like when you really have a high load. Two major critical things, right? One is your partitions might not be evenly distributed. Let's say you're trying to collect data, GPS data from every driver in every location. You might say, hey, I am trying to have some hash function based on, I mean, user ID or some random location ID, right? Assume it's a location ID. So in that sense, what would happen is the really high throughput cities or like high demand cities would have more data. And then if you extrapolate it, like assuming in this case, if you have 4 partitions, even though the data is, let's say, 50K requests per second, you would usually expect the data to be evenly distributed across all partitions. But what would happen in this case is, rather than evenly distributing data, the data would be highly loaded in that particular region. And let's say in this case, partition 3, right? For an example here, you could see all the partitions offset is like in 200s, but only partition 3 has really, really high offset. And the moment you have this, there is no way to scale your consumer to recover from the lag. You're always stuck with this lag. And unless you really do some fancy thing or some hacks, and then you're okay with dropping messages, you cannot recover from this. And then when you say the data is critical, in order to leverage even, let's say, from 12 partitions to 24 partitions, in order to leverage the scaling up, you really shouldn't be using custom partitioning. So this is something like I've seen it quite a lot. It's really hard to convince folks, but it is really heavy operation in the administration side of things as well, because as and when the partition gets overloaded, your commits, your acknowledgements, everything gets overloaded, and then only though that particular topic and partitions gets messier. So yeah, you should be really careful when you try to do custom partitioning. It should be treated as exceptional, very exceptional cases. The other part is AC case. So I think we've talked about consumers committing once we process messages, but I think this is more on the topic level, right? It's a mix of management, but you should also be wary of it when you're writing data, because in Kafka, let's say, take the previous case, right? This is partitions, but this will be replicated across multiple brokers. Let me just see whether I have an image here. So if you have broker 0, 1, 2, 3, 4, if you write to a particular topic, which usually goes into the leader, and assuming in this case, the leader is always broker 0 for our topic orders, you can say, hey, I have written successfully once I've written to broker 0, but the problem is it won't be reliable when you have broker 0 going down. So let's go into detail, right? So usually in Kafka, the topic has a lot of partitions, but the topics is also replicated in multiple brokers. So that is usually the replication factor. And if your topic is in broker 0, 1, and 3, you would ideally want it to be written to all 3 brokers before you say, hey, this is successfully written. If you say the acknowledgement is 1, what will happen to the producer is, once you write to broker 0, you will assume success. And then even though broker 1 and 3 doesn't have data, when broker 0 goes down, for that particular topic, your data is basically lost. So in that sense, you should always have AC case set to -1 or all. In that case, it assumes when you have a replication factor of 3, and then if you have 6 brokers, it writes to all 3 brokers before moving on. This is again, I think, default, but this is also linked to the broker, how it is set up, and the topics, how it is replicated and whatnot. This can also have multiple issues when you do rebalancing and whatnot. But yeah, just keep this in mind whenever you are writing data. So let me know if there is any questions, because I'm just skipping through. If there is anything which doesn't make sense, if there's anything which you think I'm wrong, do let me know. We're happy to add.
There was one question a bit earlier.
Sure. Yeah.
It just asked, what is higher? Sorry, what is higher? That person that asked, do you feel to elaborate on that? Or sharing more in the chat?
I don't know whether was it a misspell or is there something I mentioned? Can you share more detail? Oh, okay. Feel free to stop me again if there's anything. Yeah, since it's high level, since it's not code, I think I can move on a bit. But yeah, do stop me again. higher number of partitions. Oh, okay. So I think like just to sync back, like when you create a topic in Kafka, when you produce anything, like it's a event-based brokers, right? You want to write data to a particular topic. When you write something to Kafka by default, it has some default configurations, and then it usually creates, let's say, 12 partitions or 14 partitions based on your configuration. But you can choose to increase the number of partitions for each topic. Let's say, hey, your service deals with orders, but there is a different service which deals with geolocation. And geolocation would have really high throughput, let's say 100K requests per second, in comparison with, let's say, user sign up for you would be, let's say, 100 signups per second. So in that case, you can have less partitions, but the other service needs to have a high number of partitions. People use it to scale it. So when you have X number of partitions, it's almost like you have X number of boxes where you can like run something in parallel. So if you have 12 partitions, you can at the same time in parallel run 12 consumers and deal with 12 orders. But if you have 24 partitions, you can deal with 24 orders, right? So if you have 100K request, you can deal with that in one by two time of the usual response time, right? So that is to do with the partitions. And the point there is you should be really careful on how many number of partitions you are going, because it doesn't mean you can scale it to 100 partitions and 200, 300 partitions, and then you'll happily expand. Usually your producer, consumer, and other ecosystem as well have to adopt and then fix the bottleneck. And the scaling partitions not only helps, it actually hurts the system beyond some point. Yeah, that's what I mentioned about high number of partitions. Hope it answered. Like I'll move on. So there is a different, like again, like a mirror maker. Just to share context is, if you have a Kafka cluster, it's not like that is the only cluster in your whole organization. Like in our case, what used to be the scenario was for any transactional things like orders, any payments, we used to have a transactional Kafka cluster. And then a data science or a data engineering team, they usually need long retention data, or like they would do bulk operations. They don't need to worry about performance, but rather they need to worry about dealing with a lot of data, and then they generate reports or do some sort of analytics and whatnot, right? So in that sense, you have multiple clusters, and then mirror makers are used to clone data from one Kafka cluster to other Kafka cluster. And this is again super high level point, I think, but this is interesting. Like unless you've seen Kafka topic partition and offsets, this would be just a random point. But the important thing to remember is I've seen like even Kafka clusters, we would have backup clusters, or when you try to create a cluster, when sometimes like, I mean, you're trying to have a reliable clusters over time, and then it takes like sometimes you will create a new cluster, right? So even at that time, you will copy data from the source cluster to destination cluster, and then you will move some consumers from the old cluster to the new clusters. We also had to do it not just for Kafka versions, but also for like we had to move away from a particular Google VMs and versions. It was easier. It is actually manageable to move to a new cluster if you have like manageable number of consumers and producers versus changing DNS and all, like those are really tricky. So in this sense, let's go back to the flow, right? Kafka and a consumer would have a contract. In this case, which partitions is assigned to which particular consumer, and within a partition, what particular point I am currently consuming. So the same thing. So here we have 5 partitions. Each partition, there could be a you can consider it as a table of records. And then I'm reading from 0, 1 till to whatever X. And then here assume the consumer 0 is consuming partition 0, 210th record, right? But when you stop and then when you try to move to a different cluster, you cannot copy you cannot move at the exact same point because when the mirror maker is actually a consumer and producer, and then the data is all different. As far as I know, like there is a different mirror maker 2 version which can manage the offsets. I've not personally used it, but you should remember it for a particular earlier mirror maker version. When you're moving consumers from one cluster to other cluster, you might lose data. So what we used to do is we tend to have a buffer. Like if you're consuming from, let's say, T0 to T5, we don't switch it directly at T5, but rather we move the consumer's point to T3, and then we are okay with some overlapping of data. So we go back in time, we ensure we don't miss any data, and then we move on. Yeah, you just need to keep it in mind. Unless you're managing clusters, unless you're switching to different Kafka address, yeah, you don't need to worry about this. This is actually an interesting one. Ordering in Kafka, again, like there were other releases, and then you can configure Kafka to make it work. I've not personally used it in a high-scale distributed system, ensuring ordering. But personally, I would always say you cannot ensure ordering in the whole distributed ecosystem. It's not just your service, right? It's actually multiple microservices, multiple teams working on your whole humongous product, right? There's so many number of consumers, there's so many number of microservices, databases, whatnot, right? So maybe you can like deal with ordering only with the data you have in databases, right? Like it's a very small subset. But the moment you have an external service and then you say, hey, I need to have this service call always reliably done. Let's say you're making a payment from you to Tribal, moving money in credit card. That is usually always a jobs or a workers dealing with a job. Could be RabbitMQ, could be some reliable jobs, right? Even that causes multiple message produce, right? Like sometimes you're producing messages, but the receiver times out. And then you're calling a particular service, but you are timing out, and then network failures. And then there are multiple reasons which can affect the ordering. So let's take the same example, right? So you're trying to send a message and to a service, and then that service talks to database, and like you're consuming one by one messages, right? So in this case, like assume it's a database, and then we are writing some payment jobs, and you would read each and every payment job and then like process it and send it to send events back to Kafka, right? So in this case, you're reading it and then you're publishing messages, but the moment Kafka sends you an acknowledgement, the network failure could happen, right? And that time you would think that, I was not able to send message to Kafka. You will retry sending messages, even though in Kafka perspective, the message is successfully done. So in that sense, like this particular same message is duplicated, and then you can assume the same thing with some external service. You can add it here, or you can assume the same thing which can happen to some database response and queries and whatnot, right? So duplications tend to happen, which can also mess up like your ordering philosophy, right? So one is you can't ensure ordering, and the other thing is in the distributed ecosystem, there's always going to be duplicates the moment you have retries, right? Another big example is there is always exponential backup based retries on any services which is hitting another service. And then if you want to do it reliably, jobs workers is the first thing. So the second thing is you keep on retrying until it succeeds. So like you can relate to these two cases. And then if you are assuming something in your business saying, hey, my messages are going to come in order. And then if I see it's completed, it's completed. No, it's not. It's not going to be the case, because you would think, hey, you will create order, you will find driver, you will complete it, and then you will archive it. No, it's not the case. Maybe created can come at later point, the moment you have completed, or completed come before payment processed and whatnot. So you should always have a timestamp. Yeah, like I didn't add stuff here, but assume every event which is sent to Kafka has a timestamp. And then you can always see whether the message is old or whether the message is new. And then you can deal with the message accordingly. It's like, if the latest one always works, you can drop the older message. If you have some metadata, you need to update it, like depending on the use case. So I'm happy to discuss on this like later on, but do not ever assume you will have ordering and you don't need to handle duplicates in your ecosystem, because it's not just your service. There are so many services. There's so many multiple Kafka clusters could be there. You could have a consumer consuming, filtering, sending it to a different topic, and then another consumer consuming and producing to a different topic and whatnot. It purely depends on the chain of links and whatnot, right? This is again minor, but it's like, do not use single IP of Kafka cluster. Like I've seen people using single Kafka address when they try to write or consume it. Yeah, sure. Like even though you're going to get the metadata for all brokers once you consume it or try to produce it, when that particular broker goes down, you will not be able to get the metadata. So in order for the consumers and producers to consume and produce reliably, assume, like always point to a cluster, right? Because that's the whole point. You shouldn't have a single point of failure. So always have like multiple brokers in your broker list, right? Don't just point to a single broker. Yeah. Again, I think like this might look like a like philosophical point or just yarns, but since I've seen issues, and then since I've seen it really troubling, like this is also really critical, right? Like let's say, hey, you have, in this case, you have a service which is pushing to Kafka. There is somebody who's filtering, let's say, hey, I'm just filtering orders which is made on like beyond the particular payments, let's say. And then they're pushing to a Kafka, and then somebody is aggregating, and then they're pushing to Kafka, and then they're consuming from a different source. This is totally possible. But it's really easy for someone to come and say, hey, your service is not working, or Kafka is not performing well, or your database is not performing well, right? So if you don't have any visibility, it is really, really hard to have any clue on both performance side as well as on reliability side. I mean, you would be lucky. Like, I mean, of course, you need to have a lot of systems in an eventually consistent manner. But of course, there are some cases where, like let's say geolocation, right? You don't want to see the cars moving like 5 seconds later. Like the geolocation should be much more immediate. So you're okay with data loss there, but it should be really, really performant. So in that case, it was really interesting for us to figure out this, because the bottleneck, you can't just put everything on Kafka and assume it's going to work. Like, again, Kafka is not just the magical answer, right? You also need to do the benchmarking, having tracing visibility. It's not just monitoring, right? Like tracing is especially because, hey, when you send a message, what is the chain of ordering? I mean, ordering in the sense is like which services it goes to, which all databases it touches, which clusters it touches. So that way you can say, hey, oh, you have a particular issue in aggregator, because all of the places I take few microseconds or milliseconds, but aggregator takes seconds. Then you can actually go and fix it. Without this tracing information, it's really difficult to nail down the issue and then fix the performance issue. With Kafka, you can propagate the tracing in Kafka headers. Like in microservices or in HTTP, you would have propagated the data with HTTP headers or gRPC metadata. So similarly in Kafka, you'll be dealing with like using Kafka headers, and then you can like point to, I mean, you can trace and then link messages basically. Okay, so yeah, I mean, so the next few things is going to be like probably on the scaling cluster. But if there's any questions, like I can stop and then like answer for this section. If not, I'll move on to the other side. It's more of on the admin side. Anything you want me to clarify? Oh, okay. I'm assuming, like, again, I'm hoping to get more questions at the end. Okay, so this is another theory, right? Like maybe if you're a manager or if you're a CTO, you might request the platform or a DevOps team to just scale the clusters. Like here, what I mean scaling clusters is, if we go back to this particular image, we have 4 brokers, scale the number of brokers in Kafka to 10 brokers or 12 brokers, and then you have much better reliability, and then you have more distribution, less loads on each resource. Basically, you're throwing more resources at Kafka, not just memory and CPU, but rather like adding more nodes to Kafka cluster. Because if you have 3 nodes, your point of failure is higher in comparison with, let's say, if you have a 12 node, and then if you have a replication factor of 4, that has a slightly higher reliability in comparison with 5 nodes and then 3 replication factor. But there is a catch, right? It's really tricky, as I said. There are multiple factors which goes on here as well. When you scale nodes, very similar to what we saw in partitions, if you have 5 Kafka brokers, if you're adding a 6th broker, that broker doesn't have any data. And then if you don't reassign partitions, I mean, we'll touch in a bit, it's almost like you don't have evenly distributed brokers. So in this case, if you have, let's say, 10K, assume there is 100 consumers, and then you have 5 brokers. If it's evenly distributed, you would have 20 consumers reading from leaders in each broker. But in this case, if you're adding a 6th broker, only new topics and new brokers will be going to that 6th broker. So it is not evenly distributed again. And then same thing again. It's easy to add a node. I mean, not easy, but let's say, hey, you are managing it. Somehow you will do it. Same way, scaling partitions, like here you can downscale it, but it has a lot of performance side effects. Because let's take the same example, right? Assume you have a topic here in broker 0, broker 1, broker 3. It's actually multiplied, right? So if you have 3 topics, if you have 10 partitions each, you have 30 partitions. That should be distributed across. And now when you're adding a 6th broker, you have to split these partitions and then move that. And unfortunately, till now, Kafka doesn't have an efficient means to move topic from, let's say, hey, you just need to move 1 partition out of the 3 replicas to a new broker, but rather it randomly moves data. So initially, if you had leader 0 and then 1 and 2 as followers, it is not going to remove 2 and just add 6, but rather you might even have like 6 as a leader, 4 and 5 as a follower. It completely shuffles the data across. And then imagine this extrapolated with like 100K requests per second, dealing with like, let's say 10 days of data, you'll be dealing with, I don't know, like terabytes of like data. And then you can't just move everything in one shot, because that will bring the performance of the cluster. And then a lot of consumers and producers will have latency issues. So you can't do that. Like it has a really high cost of adding cluster. We used to add a node, and then we used to move partitions slowly at night whenever there is no load. And then we had to do this over a period of like weeks and months in order to finally have an evenly distributed nodes and partitions, and then finally have a like everything sorted. So if you're expecting, and then if you're saying someone to just scale up the cluster because Kafka will handle everything, no, that's not the case. I think same thing, like if you're adding nodes, replication factor, anything, if you're touching, ensure you're doing it right. And also, this is another big thing, like do not assume like the Kafka as a storage. I mean, I think again, it depends on the case. Like I've seen some people would be using it as a 30-day storage or even months. If you have a transactional requirement, you're much better off defining lower retention in terms of not just days. Like I've seen everyone taking care of retention in terms of days, like hey, any data which goes beyond 7 days, delete it. But you also have to define the limits on size, because it's very much possible that like there is an attack or there is a exceptional traffic coming in, and then you will be bombarding your disk size and a broker. So you don't want to just archive 7 days of data, but rather, let's say, every topic, every partition, if that goes beyond, let's say, 5 GB, then like clean it up, like reduce the, just set the retention. Because the moment you reach the disk space, and then the moment you reach like exceed, I don't know, 95%, your systems will crash, and then it's really hard to recover from it. So you should always have that threshold and then never hit the higher limit. So whenever you're scaling things, not only you shouldn't not only like worry about the performance side, but also about the resource limits based on your actual usage. I'm really curious. I don't know how many people have done cluster upgrades, but personally, I've not done a cluster upgrade. We've always prevented it because we don't want to deal with restarting zookeepers, restarting brokers, maintaining orders and whatnot. It's not easy. It's not easy as changing a library version. It's going to be really difficult. Like you can add on all the points you have said, like about the complication of consumer and producer and brokers and whatnot. Everything is added when you're doing migrations, right? So yeah, unless you really have a need, let's say KIP 500, there is some exceptional changes you want to accommodate. Yeah, you don't need to worry about like small patches or even minor versions, some minor versions. So you can't upgrade easily. So in that sense, like you should strive to have a reliable cluster provisioned, and then try to like monitor it properly, and then like keep it up and running for a longer time. I think yeah, like these again, I think we've touched in pieces, but the I'll just go through high level, right? Like ensure monitoring and tracing is in place, not just in Kafka server's perspective, but also in the consumer side. You should be, like, if you're asking somebody, hey, increase the number of partitions, you should be able to tell me what is your throughput right now, what is your RPS, how much time you take to consume, like process each batch, what is your latency, what is your latency distribution to database. Everything you should answer before you ask somebody else to scale things for you is what I would say. Prefer to avoid auto commits. Yeah, process it. If it's reliable, process it. And then only when you're done with your actual job, like then commit it. Yeah, when you're scaling things, you also need to worry about other dependencies, because when you scale number of partitions and number of topics and brokers, you also need to worry about like there are some consumers, there are some services which are sitting there with a small database which doesn't have indexes and whatnot, right? You will figure out the bottlenecks at different points and over time is what I would say. So when you're scaling, you are fixing the problem for yourself, but some other team, some other downstream might be facing the issue. Yeah, this is a common concept in services, but like still always assume you won't be able to process some messages in Kafka, because unless you have a custom worker, right? Like I've seen most of us, we leverage Kafka. And then if you're going from message 1, 2, 3, 4, if you're not able to process 3, you won't proceed beyond that. So like you're actually stuck at 3 if it fails. And then you would be having like 100 or 1K or 2K message in the stream, but you're stuck at 3 because of some wrong data, right? Of course, contract, there are a lot of guidelines. We used to use gRPC and whatnot, but assume it's going to fail. Assume that things will always go wrong. If you can't process a message, dump it somewhere, cold storage or a dead letter queue, and then process it later. Keep moving on. Like don't assume, hey, you'll always have correct messages. In the producer side, ensure you have right acknowledgement. Yeah, you can look at these configurations later on. Linger time is really small, but it's like you don't want to make 100 API calls, but rather you want to batch the messages when you're sending it. So ideally, if you're having high load, I would say you should read about each and every configuration which is written in the Kafka documentation and then tweak it accordingly. Yeah, avoid custom partitioning. I've added these things, I think, like recently. The conclusion slide is before because of it. The KIP 500 actually removes Zookeeper from the Kafka cluster. Like if for folks who doesn't know, like there is actually 2 components. One is Kafka, and then there is a Zookeeper, which is used as a quorum or some sort of consensus to figure out who's the leader, some sort of a voting thing, right? Like, and then it is really core and critical to the Kafka cluster. But Zookeeper, it's really difficult to do operations. So there was a lot of efforts to remove the Zookeeper. It's almost like when Zookeeper goes down, your cluster is in a chaotic state. So we never touch Zookeeper actually. And then it's not easy to restart also. So there is a, I don't know whether it's 3.0 release or there is a release which happened, which doesn't have Zookeeper, but it's just not production ready. So if you have a really high load, and then if you want to leverage it, ensure you benchmark it, ensure you wait for a while, ensure you use it in staging, and then go for the production. I think this is an interesting topic. Like I've heard people running Kafka and Kubernetes, but unless it is really small use case where they are using Kafka as a worker or RabbitMQ, I am really cautious. I'm really concerned about it because Kubernetes is meant for a different purpose. Same thing, right? Like you can't throw Kafka and then you can't put Kubernetes and then things will not magically resolve, because Kubernetes, if you don't have right resources, it keeps evicting your pods and then it keeps restarting things. And then in Kafka ecosystem, the best thing is not to touch anything. Only when you scale up resources like memory or disk, you scale it up, but you never touch it. We even had issues with GCP soft upgrades that causes a lot of latency and performance issue when it happens. Even though they say, hey, you don't face a downtime at its millisecond, we have seen that affecting us long time because of network issues. And in Kubernetes, just extrapolate, right? If you have multiple Kubernetes clusters, different teams, and then how the networking and all of that, it is really crazy. And then like when something restarts, it's not like one consumer restarts. If you have a consumer group, and then if you have 20 parallel consumers, everything will restart because you want to evenly distribute partitions across n number of consumers, right? So if you made it work, awesome. But if you're thinking about it, researching about it, I would always say you're better off with 5, 6 VMs or 12 VMs for a Kafka ecosystem rather than Kubernetes, because Kubernetes, treat it as like you can use it for microservices, but really be cautious, do a lot of load testing and benchmarking. Also chaos testing, like bring down a few things and then see how everything behaves before having it running up and running. Yeah, just don't go to prod without monitoring and alerting. I've seen like you can't have a good conversation, you can't have debug, you can't debug. Like usually it's a blame game, you can't guess and stuff. So if there is any issues at all, like add monitoring and producer consumer, your team, whenever there is inter requirements like across teams. Just ensure you have monitoring and alerting for your services. Like the biggest thing I would say is it's not like Kafka metrics is only meant for admins and DevOps. If you have some microservices which is consuming from Kafka, at any point of time, you're not consuming the messages and then you are lagging, you should have alerts to yourself, because like there would be tons of topics, tons of partitions. So it is sort of like more critical for you than others. So in that sense, like that is one big valuable thing I've seen. It helps you to figure out, hey, I am lagging in this microservices, this particular topic. So let's see what happens here and then figure out what happens in the cluster. So yeah, add monitoring and alerting. This one I've added just on the Kafka side, like if folks have done administration side, like this is a snapshot of a testing cluster. I've taken out few data, but as you could see, like the partitions should be evenly distributed. Like this cluster, it doesn't have partitions evenly distributed. You can see few brokers has less than 1.25K, and then here it's all 2 point some K, right? Ideally, it should be around like 2 point something. Everything should be 2 point something. And that also like will be correlated to all other metrics. If you have seen, those particular brokers would have a higher number of throughput, higher number of reads and writes in comparison with others. And then the broker which has less partitions would have low data. So your load is also not evenly distributed. Yeah, but data in, data out, and then leadership, partitions being down, partitions not synced, all of that you should actually monitor. This is purely from resource perspective. Again, this is testing. So this is not the standard. You should ideally look at, I mean, usually you would look at CPU, heap, disk critical in this case, but you should also look at JVM time, because we have seen if you don't have proper JVM configuration, that affects the performance as well. Again, I think like when you hit high loads, these becomes more and more critical. Yeah. I think I'll stop with that. Like I'll take questions. I think we can have a discussion rather than me just sharing it. Yeah, you can reach out to me later on as well. Happy to chat, happy to discuss anything.
You can unmute yourselves if you have any questions at this point.
Hopefully it's not a gyan or anything. Like if, I don't know how many of you have used Kafka together closely, how many of you are new to the Kafka ecosystem. Feel free to shoot me any questions, happy to answer. We can even discuss things. If you have used clusters, if you have managed clusters, you can share. We can discuss.
Dinesh, thank you so much for your presentation. That was really informational. The question I asked earlier, like you said, don't use the higher number of partitions. So what is higher? What is the number, magical number above that you'll say it is higher? So just wanted to know there, like, because I have done configuration with 500 partition, because I had to migrate billions of data from one provider to other within like 1 week. So I had to use 500 partition, and luckily it works fine for me. Okay. But there was a issue with the rebalancing. I had to like hack it or like kill the broker, kill the consumer which is not able to consume it in order to bring the cut down the rebalancing time. So I was suffering a lot. So, but that was a requirement I had to do. So, but what is the magic number of your partition? Like which, like say more than blah number is higher, like that?
Yeah, again, I think like this worked for us. Like if there is I think we can talk in terms of mapping, right? You said you had more time, but in our case, it was like millions of orders happening concurrently at any particular second. And then for us, let's say 100K RPS. And for that also, like we didn't go beyond 50, 60, if I remember right. So anything beyond 50 itself, like I would question about the producers and consumers metrics and then processing time. Because if you're, I mean, if you are processing in milliseconds or micros, you don't need to worry about like that many partitions, right? Because I would say you should optimize your processing time rather than parallelizing it. So in my opinion, I would say, hey, if anyone goes beyond 50 itself, I have to really look at other metrics and then question and then see the benchmark and scale it. Again, that was an exceptional case. For all other services, we were fine with like just 12 and 24. Like 12, it was too low for us. 24 worked really well, even from small services to like 20K RPS, 50K RPS. It was fine for us. Because when you have more time, I don't know, like it's not, I'm not sure whether you said, hey, you needed 500 partitions, you had to finish all the jobs within 7 days. But in that case, you have much more luxury. But in our case, the metrics was like, hey, I should not be lagging beyond 2 seconds. Or like imagine OTPs. We used to send OTPs with events, and then anything which is late done, like let's say 20 seconds is useless, right? So and we never had to go beyond 100 is what I would say. So maybe others can pitch in as well. But yeah, like anything beyond 100 seems really odd to me. But if there is, because if you have 500 partitions, you have so many consumers, and then if one consumer restarts, you're actually restarting 500 consumers, and then that rebalancing itself is so high. So I think it purely depends on the specific metrics and then more visibility, and yeah.
Thanks, Dinesh. There is a question from Michael Richards. You want to answer that as well in the chat?
Sure. Over-provision the cluster and the anticipation for future growth. Repartition. So yeah, I think not over-provisioning, because when we over-provision it, of course, like the number of like we tried something like 30 node cluster with higher number of replication factor. But that also, we have seen the side effect in like increased ACK, right? Like your produce time increases, and in-sync replication time increased. And again, like it's tricky, because if you want to have your Kafka cluster in a regional setup, like multi-regional setup, you have different zones, and then that also affects like along with the networking, right? So we have seen issues as well with higher over-provisioning. But like I think like, as I mentioned, I'm not sure whether somebody noticed, we eventually settled with a different number of clusters with a different configuration rather than one cluster for all. I'll give you an example, right? As I said, transaction cluster has 7 days of archival. Anything beyond 2 GB, we don't allow it, because you're supposed to consume and then finish within seconds. Why do you need 7 days? Like we even moved to 3 days for high load topics. But for data science and data engineering, we had a different cluster with a different retention policies. There we had like higher disks, higher CPUs, but same nodes worked for us fine. Like we had, our magic number was like 12 Kafka cluster nodes. So I would say don't over provision it. Like you don't need to over provision 2-3x. But like I think the better answer is load test it, right? If you're expecting 100K requests per second, you should always benchmark for, let's say, 1 million requests per second. And I think even for that scale, the number of nodes wouldn't be an issue, unless you're going, I don't know, like from 1 million to 1 billion messages, maybe. But within this aspect, like 100K to, let's say, 1 million to 10 million, the number of nodes wouldn't be that huge. So if you haven't grown if you are experimenting, you can try with the different environments. Like load testing cluster could be higher, but if you over provision it, as I said, right, like it's hard to cut the resources, and then you don't want to have a lot of cost as well, right? Yeah, but by the way, others also feel free to pitch in. Like this is just personal experience. There could be other experiences which worked with over provisioning as well. So don't go with like 3 nodes or just 4 nodes. If you have a really high throughput, lot of data, yeah, go with 6, 12, right? Yeah. It does work with Kubernetes. Yeah, I'm happy to hear, Rahul. Like you can share more data, but it's just that, like, I think like there is a lot of other variables which people need to worry about. Let's say, hey, if there is new consumers somebody is writing, and then they don't have a process, they don't have a correct resource limits with Kubernetes, the Kubernetes will kick them out, and then that would cause rebalancing, and then that would cause lags and whatnot, right? And also same thing, right? Like if you have a proper disk, that's great. Like of course the state is different, but if any Kafka VMs is kicked out, like hopefully it's not kicked out, that causes a lot of trouble. And I'm not sure whether you had to expose to, like if you have a need for exposing to public or interdependent teams and different orgs and whatnot, it get complex over there. Maybe for a small use case, great. If it works, awesome. But there is a lot of things which somebody needs to worry about, like load balancing. I don't know how you're managing DNS. All of that is really tricky, right? Like, because everything is ephemeral. Even DNS, unless you don't configure it properly, it changes the IP address and whatnot. So the Kubernetes brings in additional variables for you to run much more reliable Kafka is what I feel. But yeah, like happy to like you should actually share. Like I'm open to hearing how people actually make it work for Kubernetes as well.
Yeah, I can actually share it after a while, because our organization is actually planning to move to Kubernetes for Kafka. We haven't done yet. We are still running it on premise. So yeah, hopefully in the next few months, probably in the next 6 months, we might be moving there.
May I know, like, what is your load? How many consumers, how many producers you have? Like just an abstract number.
I don't have exact metrics, but yeah, we are using 10 brokers. So yeah, 10 brokers and completely loaded. So it's a organization-wide Kafka cluster.
Okay. Yeah, so we actually reached a point where we have no clue on how many number of consumers are running, because there's so many consumers consuming and then reproducing and what to Kafka, right? So we had like more than 500 to, I don't know, 2000 consumers in multiple clusters and whatnot. So it just added so many things. Like when we migrate and all of that, that's when we realized how tricky it was, because we couldn't put a system architecture or a acyclic graph of the Kafka ecosystem, right? Because as your R grows, it is really tricky. But I think if you're in early stages, great. The only thing is, again, if it doesn't work out, it's really hard to move all consumers and producers without losing data.
Yeah, those are some of the challenges we are actually looking at. If it is a good idea to move, we will definitely be taking the help of a vendor. We won't be doing it ourselves for sure.
Mm-hmm.
At this point, we have around 20,000 partitions in our Kafka cluster. So yeah, it's not that huge, but yeah, it's huge.
Yeah, the same thing, right? Like how will you scale a particular, like let's take an example, right? You are having 10 brokers, and then you are just adding a new broker, and then in Kubernetes context, it's just a pod. But
yep,
the operator can actually restart everything, right? Like it depends on the operator. And let's say you are adding in just more disk space, but all brokers will be restarted. Like you don't have a flexibility of out of this 10 VM, like we have seen this multiple times, out of this 10 VMs, one VM takes a lot of hit. Okay, we'll just increase more CPU and more disk for now to that. But that is out of the questions anymore as well. So yeah, like ideally I would say, hey, you should list all of the issues. You should you should actually talk to somebody who's used it in production for years, because you'll not find issues right now. Like if you're running for months and months, then maybe you will see things. So yeah, like maybe somebody who run it in prod is a better person to answer, I guess.
Yeah, true.
Any other question which I missed? Anthony, yeah, anyone, like feel free to pitch in. I'm not sure whether it was like you couldn't relate, because a lot of things, I think this is over 5+ years of things for me. But if you're just looking at from microservices point, I think maybe some of this is not relatable. But again, as I said, like feel free to ask. Happy to share more context. Any other questions?
I think you answered the ones in the chat as well. So
Cool.
anyone has anything else? But this meetup was recorded, and I will share the recording tomorrow on the Meetup Hub and also within the meetup groups. But no one else has anything. Thank you all for joining, and thank you all for our speaker for this awesome presentation. Have a great night, everyone.
Yeah, happy to like chat. Like I'm also really curious if anyone have questions, or I'm also curious on how we are running things in prod. Like feel free to hit me on Twitter, like DM me, or in Confluence Slack as well. Like you can find me on Slack as well. So yeah, thanks folks. Thanks Anthony for organizing this.
Yeah, sure thing.
Thanks, guys.
Great. Thank you.
All right, take care,
Thank
everyone.
you.